This video is a collection of notes on wiring the control system, especially in regard to our exercise. We'll start with the pneumatics control module. I've taken this knife switch and used it to emulate the pressure switch that's on the system. The robot is enabled. It has code. If you see right here, there's a light that's on. This means the compressor is running, and now it's off. When you go to a competition and the inspector is inspecting the robot, they'll put a jumper across the compressor switch to do some testing, and that's all they're doing right here, is to force the compressor to come on. The next thing you can do to test your code is I have this Xbox controller. This is in our exercise. We program these 4 buttons to operate 4 pneumatic solenoids, and the lights will come on, and that's your feedback to see that the code is actually working. You don't need an actual solenoid hooked up. That's an electrical problem. If you get the light, the software is okay. I'll swing this unit around without dropping it. And this is back to the, well, let's just come back here a second. These are the PWM style speed controllers. This particular model is obsolete. That's the Victor SP. There are many predecessors. It's also the same port used for servos. PWM is a one-way communications. You can actually write code and test your product even without having any devices hooked up. If you do have speed controllers hooked up, by looking at these lights, you can tell if you're going forwards or backwards. The lights will turn green. They can be red, they can be yellow. It's going around it here. Let's talk about the CAN bus wiring. Starting on the back side is the power distribution board. You have the CAN bus coming out here. It went around to the other side. Starting here at the power distribution board is the CAN bus. There's a terminator on this end. The CAN bus is a string of devices that's serially connected. There has to be a terminator on each end. The power distribution board has a terminator built in. You don't have to worry about it. Just bring it around, connect it to any CAN bus device. In this example, we started with the pneumatic control module. That didn't have to be the first one. It could have been a Talon or a Victor. We come around here and we keep going. We do not go to the Robo Rio yet. That's the last thing on the bus. One end of the bus is the Robo Rio. The other end is the power distribution board. All the other CAN devices just connect serially in the middle. I've broken this out so we can review. This is the CAN bus. It comes from here to there. Another loop comes out, goes to the next one. Another loop comes out, goes to the next one, so on and so forth. This one came from the pneumatics control module to here, to there, to there, and then back around to wherever it went to, which in this case is this. The Victors come with a connector like this on the end. This is the same connector that can go into the PWM connector. If you use it as a PWM device, just plug into the front, take the other wire and just cap it off. Make sure the 2 wires are not shorted together. If you do it this way, the way I create an adapter for the bus, instead of cutting the connector off, you just take a PWM cable, you cut it in half, you plug one into here, splice it to wherever you need to go, take the other end and connect it appropriately somewhere else. So this is a shell that will hold these connectors together. I advise you use that. So that's together. There's another shell, but the Talons come without the connectors. They just have bare wire. So what I do is we take a PWM cable, we cut it in half and splice it to the bare wire, and then use a shell to connect that together, and you just keep going. This is the Mach Talon SRX Breakout board. A cool feature of it is it has the 5 pins for an encoder. It's the same 5 pins that's on this Gray Hill. You can make your own cable using the Polu connector kits. to go straight across. These other two pairs of pins right here are for limit switches. If you use limit switches here, it requires no software development. It will work great. This is more of the Pololu wires. I put them into a 2-pin header shell and plugged it in. And you can, let's see if you can see that. So see the red light, that means we've hit a limit switch. It's hard to see there. There you go. Here's the other limit switch there. One limit switch stops in one direction, the other limit switch stops in the other direction. So yeah, if you have an elevator with a limit switch on each end, you have a top and a bottom stop. When we get to the CAN bus programming, there's even a software feature called auto reset. The reason you do that is we use the encoder to keep, let's just say this is an elevator application. You can use the encoder to keep track of where the lift is. When it gets to the bottom, you're going to want it to reset the counter to 0 so you know where you are, and we can program the CAN controller to do that. So this controller with this breakout board and these wires from Pololu can make your life real easy in a hurry. One more quick little issue. We're going to come on around here. There are several different size fuses that we use on our team. We have 5, 10, 20, and 30 amp fuses. And then we have the 40 amp fuses, what we put up here for the big motors and stuff. I have a 5 amp fuse here because I had something small connected up. If you have a small wire, you got to have a small fuse. You can't have a big fuse in a small wire. It's a dangerous situation. The best way to figure out what size fuses you'll need compared to the wire sizes is look in your FRC manual for the robot rules, and it has a table that will tell you. Through the magic of Hollywood, I just stepped away and put some code on here so I can show you the blinking lights on these PWM controllers. Got a green flashing light here because I'm driving one direction, there's the other direction, and so on and so forth. This is on my left throttle, this one's on the right. I don't know why this one's not running. Maybe I don't have a fuse. Yep, maybe I don't have a fuse. Let's put a fuse in. Let's try it now. And there you go. Code works, hardware works, and that's how you wire up a PWM and all the rest. Good luck. The easiest way to get these connectors and these pre-made wires is from Pololu. Here I have a 5-pin, a 3-pin, and a 2-pin header and an example wire. We're looking into the side of the wire. Facing up, if you're going straight up in the paper, is a little spring latch. The spring latch has to be up and it will pop up through the little hole in the picture. That's the correct orientation. Here it is starting to slide in. The hole in the connector is facing up, the latch is pointing up. You can see we're looking into the side of the wire. I recently purchased this gear motor from off of Amazon. You can get the same ones from Pololu. It comes with a 6-pin header, and by sticking an X-Acto knife up under the little plastic tab, you can fold it up and break it, or lift it up enough to be able to slide the wire out. That's what captivates the pin in. The easiest way to do this is take the wire, push it all the way to the right, take an X-Acto knife or some small pin, lift the plastic up, being careful not to damage the spring or the connector pin. After I pulled all the pins out, I reinserted them into blank shells with the wiring that I wanted. At the bottom here, bottom right, is the connector pinout, the same as the Gray Hill connector. It's the same connector that can plug straight into the mock Talon SRX breakout board. The other connector, I just fitted it to go into a PWM cable This motor has a very low current draw. This is not a legal motor for FRC. It was just for the test bed. And I would cut a PWM cable in half and take the other half and plug it into the power distribution board with a very small fuse like the 5-amp one. Here you can see the 5 pins on the Gray Hill connector, the 5 pins on this cable, and the 5 pins on the mock Talon board. There it is laid out again. The cable on the left I just made from the Pololo pre-made cables, and the 5-pin shells. It's the same pin out on each end. You can plug one end into the Gray Hill connector, the other end into the mock Talon SRX board. This is an example of the small hobby motor with the new connectors fitted on it plugged into the mock Talon board. The Gray Hill plugged into the mock Talon board, and the board by itself. This is the mock Talon board with the 5-pin encoder cables, the 2 limit switch connections, and the 3-pin analog connection. This is the older model Victor SP. It's PWM only. I have ferrules on each end to make the wire management a whole lot easier.